So I'm going to talk about submarine swaps and loops. Um, so the idea of submarine swaps, that's something that I was working on ways back. Um, and kind of the idea is that although we have Lightning Network, um, and it's great, it has different characteristics from the blockchain. So in the Lightning Network, we have this thing called flow. We have where it's a flow constrained network. So you can only really send as much as you'd establish in your capacity of your channels, right? And then when that's depleted, then you're kind of stuck. Um, whereas with the blockchain, we don't have the same restrictions because the blockchain has this UTXO model, which is a broadcast model. So you broadcast your transaction, and then everybody adds it into this shared synchronized state. So the blockchain has a lot of really good characteristics. Like, if I'm not able to send to you off chain, it's awesome if I could go on chain and be able to use that as like a fallback option at potentially an increased cost because of that global broadcast that makes Lightning compelling in the first place. Okay, so the thing that I was thinking about when I was working on the submarine swaps originally is that what if I just took the same kind of concept that Lightning has of this HTLC, and I just said, let's sometimes go to the chain when we need to go to the chain. So when we do hit this flow constraint, what if we just go to the chain to solve the flow constraint? So I took a look at the Lightning HTLCs are actually kind of complicated. There's lots of pieces in there to deal with channel states. So I took a look at like what's a bare form of the HTLC contract, and you can see it up here. I guess you guys have already covered how Bitcoin script works, but basically what it's doing is it's saying let's give me some proving information. And if the proving information is if you give me the pre-image that matches a hash that's committed to in this script, then I'm going to allow you to use pubkey 1. And otherwise, let's say you don't give me the hash that matches that pre-image, then I'm going to introduce a time delay, and we're going to use pubkey 2. And this is kind of like a simplified form of it's not exactly the script, but that's a general idea. You have one pub key that is used when the pre-image is revealed, and you have another pub key that is used when a certain time passes. And because this is script, we get the benefit of SegWit to reduce the bytes. So even though we're introducing an extra pub key to like a normal spend, it's not so bad. We get 19 extra V bytes. So just to reiterate, like to get back to basics about how HTLCs work, you have these two execution paths. The first execution path is the pre-image is revealed, and we do the hash. We check it. We check the hash of the pre-image versus the hash it's committed to in the script, and then we say that's equal. So let's use Alice's pub key. Let's use the success pub key. And the interesting thing to think about here, as far as potentially attacking an HTLC, is that Bitcoin doesn't have this concept of the reverse of a time lock. So the success path can always be taken. It's only after a certain amount of time that the other path opens up. But now both paths are open. So that's pretty important to think about. And I'll get into so let me talk about the second path. The second path is the timeout path. That's what happens if this HTLC, no pre-image is revealed. Instead, the funds have to revert back so that they're not stuck for eternity if the pre-image isn't revealed. So in that case, we wait for the CLTV height, and that's reflected in the lock time of the transaction. And we say, okay, is CLTV height greater than this number? And if it is, now the second path opens up, and Bob's pub key can now spend this transaction. But what happens if the success path is initiated, and it's at fee 1 Satoshi per byte. And then the fee market ramps up. And so now fees are, the cost to enter the blockchain is now 100 Satoshis per byte. Does anybody know what happens? So this is a problem for HTLCs. You're in a race now. So once I've revealed the pre-image to the world, that's what I'm doing when I broadcast this pre-image to try to get the success case. I've now revealed it to the other side, so I can't take it back, right? And so what I need to do is I need to ramp up my fees, because otherwise the timeout is gonna initiate. And remember, we've locked these HTLCs potentially to other people, so other people can use that pre-image information to take that money. So what we need to do is, this is something important to think about, is that whenever you enter into this, whenever you set up these HTLC contracts, you need to make sure that once you reveal the pre-image, that you really definitely get it in before that timeout hits, and that is fee dependent. Okay, so I made this Submarine Swaps project as like an open source project, kind of like as a prototype to show people like kind of the concept. And one cool thing about this is that it's a very simple script that can have different variations. So Lightning is kind of like a lockdown protocol. If you change it, the other node won't understand what you're saying, so you're going to have to negotiate with them. But if you just have the submarine swaps system, as long as you speak the language of HTLC at a high level, you can interact with the Lightning Network and then customize it to how you like it. So one thing that I've seen is there's been Moon Wallet has integrated submarine swaps, and Breeze Wallet has integrated submarine swaps, and of course Lightning Labs were working on integrating submarine swaps into our app. And so one variation I've seen is to change CLTV into CSV. I don't really know actually why they did that, but as soon as you broadcast the transaction to the chain, it basically becomes a CLTV. It just makes your life like more complicated about reasoning about like, okay, where's the forcing function to get me to actually broadcast to the chain? One thing that we've introduced in our contract is op size. So in the Lightning Loop contract, we include the size parameter to check that the pre-image is the correct size. Does anybody know why that's a good idea? Okay, so including the size is a good idea because the pre-image, all I'm seeing of this pre-image is a hash, right? So what if you gave me like a crazy length pre-image, but it still corresponds to this hash? Then I'm gonna be stuck potentially. So in my original script, I removed the op size because I knew that on the other side that the size was being checked. Like in a normal Lightning contract, the size is already checked. So the way the flow of my original submarine swaps contract would work is that I would make a Lightning payment that corresponds to an incoming on-chain submarine swaps HTLC. So since I know that I'm already entering into this contract that checks that the pre-image size is what I think it's going to be, I don't need to check it on the other side. But in Lightning Labs, we actually reintroduce the op size just to be safe and consistent. Another variation that I think Breeze uses, and that I also added to my original submarine swaps, is to use a hash check on the pub key. So the reason I did this originally is because I wanted you to be able to get your private keys from your Bitcoin core. And Bitcoin core doesn't have a way to just like say, here is private key. So what I did is but it does have a way to say, get private key for address. So what I told people to do was make an address and then dump the private key out. And that's a potential advantage, but it wastes more space because now you have the hash and you have the pub key. And another thing that isn't being used, which I think could be potentially useful with submarine swaps, is that you have the success case and you have the refund case, and in those cases we have like Alice pub key and Bob pub key. And one thing that is hard to do in Lightning is to represent multisig, because all the contracts are oriented around this idea that I control my node. But with submarine swaps, we don't really have that constraint. So you can say that the refund case maybe goes to 2 different keys or 3 different keys, or 2 of 3, if that matches your wallet. So if you're somebody who's like in an exchange, and your exchange, the way that you manage your keys is always in a 2 of 3 configuration, you can say that either this succeeds and the Lightning payment is executed, or it reverts back to that normal control that I have with 2 of 3. Okay, so as far as like use cases, like why would you want submarine swaps? So there's 2 directions to the submarine swap. There's one direction which is like you're going into Lightning, and there's another direction which is you're going out of Lightning. So if you're going into Lightning, maybe you have your Lightning wallet, and you've been using it for months and months, and you've paid your phone bills, you've ordered lots of pizzas, and now your funds are kind of depleted, and you have one option to deal with this situation, which is that you can go to your exchange or your cold wallet, wherever you keep your bitcoins that are on chain, your normal funds, and you can just go and put them on your Lightning wallet and then make a new channel, and that will allow you to continue spending. But it's kind of not a great situation for the people who you're making channels with. So if you think about like on the other side of this equation, like let's say I'm a routing node, I'm your peer. So what you're doing is continually dumping liquidity on me and leaving me with these ever-growing set of channels that I can't really route through because you're a mobile wallet. So you're making my life worse and worse over time, because I'm on the opposite side, right? I'm getting more and more of your funds. So what I'm going to really have to do to correct the situation is I'm going to have to close a channel and take those funds and reallocate them myself. So another option is to use a submarine swap so that we kind of can abstract this whole idea of where the chain transaction happens and how it happens. So we can say that instead of creating the new channel, what you can do is you can do a submarine swap where you pay a swap provider, the submarine swap provider, in a non-custodial way using the HTLC, and you can withdraw from your exchange into this swap contract, and then the swap provider will pay through the network back into your wallet, and now the situation is fixed with your peer. Your peer no longer is sitting on a bunch of coins that they can't really route. Now that channel lifetime can be extended, and they're going to get some more fees. So your peers might be happier if you do this type of operation. Okay, so and when I originally made submarine swaps, another thing I was thinking about is that the chain is expensive, but it's not the only settlement mechanism in the world. So we have Lightning and we have the chain itself, but we also have other chains. We have side chains, and potentially you could use their lower security guarantees for a temporary operation where you're moving money around. So if you want to use some side chain to just kind of execute this balance change, then it's not so bad that you're just temporarily moving money around using that tool. Although with Lightning Labs we have only Bitcoin on chain and off chain. Okay, so another use for like a submarine swap is, let's say that you have your cold wallet. You're the type of person who's a real hodler and you rarely spend, and you want to keep your funds on your Trezor. You don't want to play around with this new technology, but you see something you really want, like that Blockstream hoodie is something you want to get. So a submarine swap is a way to do kind of a temporary buy. So you leverage the ability of somebody else to have this liquidity, and do all the pathfinding and all the running of the node and the hot wallet and all that stuff. And so in this way, you can go from your Trezor to the swap provider, and the swap provider will make that purchase, and it's non-custodial. And the worst case that happens is that the funds are refunded. Okay, so when I originally did submarine swaps, I did the swap in case, but actually the swap out case is pretty cool. I think it maybe even it's more useful for like the problems that I see like people reporting with Lightning today. So Lightning Labs, we did loop out first. We did the out case, move your funds out of Lightning. And the reason you'd want to do that is, okay, first maybe in the reverse case, maybe the store that you're soliciting is not a user of Lightning. They only accept the old school on-chain Bitcoin, or maybe it's an exchange. But you're living in the future. You've got your Lightning wallet, so all your funds are all the funds that you've allocated to spending are in Lightning in your Lightning balance. So you can go in the reverse direction. You can say, I'm going to spend down my Lightning balance, and then somebody else will take care of. And I want to retain my channel. I don't want to mess with my existing channels. I just want to draw down my balance a bit. So you can kind of outsource this to the swap provider. Another thing you can do is, okay, probably the biggest use case is I want to get some inbound liquidity. I really want somebody to commit some capital in my direction. And there's a brute force way to do this, which is just to pay somebody to commit some capital in your direction. That's certainly an option, and it's something that I've offered on yalls.org, and I think that there's like kind of a nascent market for it. But it has a limitation, which is that I don't have as wide of a selection of nodes to get this inbound liquidity as I otherwise could have. So imagine if I wanted to like find the node in the network that has the totally lowest fee rates. They just are crazy. They put in like 0 fee rates. I can connect to them, and what I can do with the swap is I can spend down that channel. So my Lightning channel balance becomes maybe more even, and then I spend it in the direction of the swap provider. And then the swap provider, in a non-custodial way, will send back that HTLC back to me on chain, so that I'll get my funds back, so that I'll be able to spend them. Because that's the advice that I usually give to people. Like if they want to be able to receive, easy. All you have to do is spend some. Go buy some stuff on go buy some Amazon gift cards or something. But this is a way where if you're not in the market for buying something at the moment, but you do want to receive, that you can spend down your channel some, and now you're able to receive. And without trusting some custodian, without pushing your funds to an exchange, that kind of thing. Okay. Another use case is that if you are running a service on the Lightning Network, you're typically operating like a hot wallet, and you've got some funds at risk. And every day, more and more funds probably are stacking up in your hot wallet as people make purchases. And in theory, in the absolute idealized world of how Lightning could work, is that funds are moving back and forth perfectly bidirectionally. So the store is getting some payments in, and then at the end of the day, they pay all their employees. But in reality, of course, there's going to be things aren't going to work that perfectly, right? There's going to be some disparity. So stores probably are going to be sinks, and people on their phones are going to be dumping. So we need to think about that use case. Like if I'm a merchant, I want to like limit my risk. I don't want to have a hot wallet that has so much money in it, and I also have the same liquidity desires of just a regular person who wants to receive on their phone. So they can also use this swap providing service. They can say, at the end of the day, I've received 1,000 payments, but it's really stacked up a lot of Satoshis on my balance. So what I want to do is I want to reset to the start of the day. So what I'm going to do is I'm going to pay this loop service these Satoshis that I've received on Lightning, and then I'm going to get them back, and potentially I'm going to get them back into like my exchange. Or I'm going to get them back into my cold wallet. And so then I'm ready for the next day to keep doing business. And it can also be useful just when you're starting up your business. If you need to be able to ensure that somebody can start paying you, you can just initiate this swap provider, you could connect to a bunch of different nodes, and you could loop out through all of these different nodes, and now you have pretty broad coverage. So if somebody's in some weird position in the network, the chance is higher that they'll be able to pay you. Okay, so that's why submarine swaps are cool. So here's why submarine swaps are really bad. There is some really big problems with submarine swaps. One thing is that we're kind of going against the whole idea of Lightning in the first place. We wanted to get off the chain, but now this is going back onto the chain, which means that it's going to cost a bunch of money. That's not good. Every time you're doing one of these swaps, half of it is off the chain, but the other half you pay these high chain costs. And even off the chain, you have to think that off-chain operations still have some kind of indirect chain costs associated with them because of liquidity needs to be balanced in some way. Okay, so another problem is in a submarine swap, you have the user experience on Lightning, hopefully, that things are going instantly. Like you are paying and it's working. And so one thing that's tempting to use submarine swaps for is to kind of use it for situations where like liquidity is a problem, and then you could like fall back into a submarine swap. But because it's a chain transaction, you might have to wait a while for that to be secure because you're just going to have to wait for confirmations. So every submarine swap, you're going to have a waiting period. And after you've experienced like the speed of Lightning, going back to the chain is a real bummer. Like I don't like it. I want to stay on Lightning all the time. Okay, so the other thing that's a big problem with submarine swaps is that they have the worst case. They bring along the worst case scenario of Lightning, which is that your HTLC goes to chain, and now everybody in the world can see that pre-image, and they can see that UTXO, and it's even like more identifiable. Like, oh, you did this submarine swap, so I see your UTXOs are kind of like tainted with this concept that you're a swapper. And now I can see the pre-image maybe. So if I know that pre-image is related to a payment, then I'm compromising your privacy in that way. So there's privacy trade-offs. Okay, so I'll just go through the kind of some solutions that we have in mind to fix these trade-offs or address them at least. And so the first thing to think about is like that chain cost, right? Not only are we paying a cost, we're also incurring a cost onto the shared resources of the blockchain. So what we want to do is we want to minimize that cost. And so to minimize the cost, the best way to do it is to like analyze what exactly we're doing. So here is the transactions that comprise the submarine swap. The first transaction is kind of like the funding transaction. I deposit money into this HTLC. I set up funds into the HTLC, and I wait for them to confirm so that they can resolve in one of those two ways. And you can see that I've like listed out the bytes, the V bytes here. So the funding transaction is going to take 123 V bytes, and then if you potentially have change, which is pretty common, it'll take extra. Depending on the address type, it'll take maybe 30 extra V bytes to represent that extra change output. Plus, you have to think about the sweep cost of the UTXO cost of that change output. And I've kind of like written out in numbers each of these different components, how they're represented in V bytes. So you can see that what's like really taking up a lot of V bytes. It's the out point, like what UTXO am I using, and it's where am I sending the money, like the value plus that script of where I'm sending the money, and then because we have the SegWit benefit potentially, to a lesser degree, also the signature and the public key of just sending money around in the normal way. That's some V bytes. Although, and interestingly enough, though, the transaction itself is there's not a huge overhead of the transaction wrapping of like the version and the lock time. Okay, so now I've deposited funds onto the chain, and I need to resolve this. So the way that I'm going to resolve it is I'm going to reveal the pre-image, and I'm going to use that pre-image to sweep it back in the success case. So what does that transaction look like? It looks, like a normal transaction, but it has like kind of a beefy witness component, right? It's got both of those pub keys in there. It's got the pre-image in there. It's got signature. So this is kind of like um, all told, we're talking about maybe 300 virtual bytes, which is maybe twice as big as a normal transaction would be. Okay, so oh yeah, question. Oh yeah, you're getting ahead of me. Yeah, yeah, but this is the problem. This is the problem. So this is why, like, what's motivating these script improvements? It's because people are making weird scripts. Um, okay, so um, let's start to get into the solution part, which is something that I codenamed Hyperloop. It's like we have the loop project, but we need to kind of supercharge it. Like if we really want to run this operation, if it's useful to people. So the first iteration of loop is just to think, is this a useful service? And like try to get people on board with it in a limited way to see if it's solving problems and the people want to use it. When I released Submarine Swaps originally, I wasn't sure. Maybe this isn't, exactly what's needed, and I released it in a way which was designed for altcoin swapping. And now I'm designing it more for dealing with Lightning user problems. So there's, this is something we're addressing in an iterative way. So the first thing that we're thinking about for changing swaps is to not make them submarine swaps at all. Instead, to make them like kind of more like channels. So the way that it would work is you would, instead of representing the HTLC on chain, that you would, just like a Lightning channel, you would deposit into a multisig. And the multisig would then create this potential HTLC that everybody would get their signatures on. And then you can see that's like represented by the dotted circle. So before we deposit in, just like with Lightning, we line up our transactions with signatures, and we do it in a phased way so that we always know that we can get our money back. And then when it comes time to actually do that pre-image reveal, we say, wait a minute, we have this HTLC that could go to chain, but why should we do that in the first place? Instead, we should just agree on a cooperative transaction that removes that script, that pre-image, and we just do a normal, kind of like a cooperative close of a channel. So that will solve the problem of revealing the pre-image on the chain. And if we have script improvements, it will be a cost. It could potentially lower the cost because we can use Musig to combine signatures together. So it would just look like a normal pay to public key to go into this, and going out would look like a normal pay to public key. So you would no longer be able to identify it as a swap. Just like in the future with Lightning channels, hopefully we will no longer be able to identify them on chain as Lightning channels. Okay, this is where it gets complicated. So let's expand on that idea that we have the multiple signatures. So I don't know if you know how multiple signatures, like the Musig, works. And at Lightning Labs, we've been working on this thing called two-party ECDSA, which is like a gnarly version of Musig that works with ECDSA. But the basic idea is that you have, let's say you have a bunch of people, maybe two people. You have two people who are signing in a 2 of 2. What if you could collapse those signatures? You could collapse the two signatures into one signature. That would be good for privacy. It'd be good for saving you money. But the really cool thing is there is no real limit to how many signatures that you can collapse into one signature. So potentially, we could have 100 signatures. We could have 100 people enter into this contract, and we could collapse those 100 signatures into one signature. So we get privacy for 100 people, and we would also get 100x savings on that signature. So the idea of the Hyperloop is that we're going to add in more and more keys into this limited time kind of Hyperloop channel. And that's going to be a big benefit to us because we're going to get these signature savings. And another benefit that we're going to get is, so this is representing the swap in case, and in loop we call it loop in. So in this case, what we're doing is we're refilling a bunch of channels. We're trying to refill everybody's channels. Everybody spent down their channels, and now they're trying to refill them all. So another cool thing that we can do is, let's say you have like 5 channels, and all those 5 channels have been emptied. So because we have this potential to use atomic multipath payment, we can tie all of these. We can tie the many off-chain payments into one on-chain payment by using AMP. So you could refill 5 channels or however many channels you want, and we don't even need a complex version of AMP. All we really need is a base AMP that I talked about before, which is this idea of economic AMP. And how it works is that, just to reiterate, is like you are locking more and more HTLCs to me to increase the value up into a point where it makes economic sense for me to send out an HTLC on the other side. So we're getting savings. That's also kind of like a potential 100x if you had 100 channels, that you could do them all with one on-chain transaction. Instead of doing each submarine swap as they are today, where one channel refill equals one on-chain transaction. Did you have a question?
Yeah, I don't see exactly the workflow. So you have Alex, Bob, Carol, and Dave. They send you a transaction, an on-chain transaction. At the same time, they are doing AMP towards the swap provider, or?
Oh, it's very much just like the normal base AMP case. So let's imagine that. Let's go back. Did I put something here? No. Okay. So let's say I put this. Here's the normal swap flow, right? You have the success and the timeout. So and let's forget about all the different keys and all the other optimizations. Let's just go back to this one case where I'm doing 2 off-chain to equal 1 on-chain. So the way it works is, before I'm going to go on-chain, before I move an HTLC out, I want to make sure that I'm going to get reimbursed, right? So that's the way that normally Lightning works, is that I'm going to get an HTLC locked to me. So we talk about this. I'm like, I want you to send 2 out. So I notice that an HTLC of value 1 comes into me, and I'm like, I'm not going to send 2 out. And then I notice that another HTLC of value 1 comes into me, the same pre-image. And now I think, now it makes economic sense for me to allow that 2 to leave to that one pre-image, because I'm going to be able to off-chain take those 2 incoming HTLCs with that pre-image. So that pre-image is now worth 2 to me. Or it was always worth 2 to me, but now it's worth it to me to release a pre-image so that I can take those 2 incoming HTLCs that are locked in the commitment transaction outputs.
Yeah, I mean the 2 HTLC are offered off-chain, so you release a pre-image, and so now Honey symbols are able to claim the output on-chain, right?
Now, what is able to claim this?
Yeah. Because if you release the pre-image to claim the HTLC, now they have the pre-image and they're able to claim it on-chain, right? Oh.
It works almost identically to, like, you don't even have to think about it being off-chain. So we could think about the entire thing on-chain, right?
Yeah, but just to see the workflow with both off-chain and on-chain, because clear.
The goal is to reduce on-chain footprints by aggregating basically the operation for several users, right?
Right. So, like the way that a normal Lightning workflow works is, somebody comes to me and they're like, if you locked an HTLC out, that would you would get reimbursed for HTLCs that the money that you're sending out will be reimbursed on the other side by money that's coming in. Yeah. Well, we don't have to think about on-chain or off-chain. Yeah. So if you make one HTLC that goes out that's of value 2, and you have 2 HTLCs that are coming in that are each of value 1, now it makes sense for you to carry that operation forward. Before when you only got one HTLC locked to you of value 1, it didn't make sense to you to lock an HTLC out of value 2. You had to wait for the second HTLC to be locked to you, a value 1. And now it makes sense for you to lock an HTLC out of paying 2. And in between there's also like a fee, which makes it economically reasonable to do this. And so with the submarine swap case, on the outgoing side, it's one on-chain transaction. And because of AMP, we have many off-chain HTLCs coming in. And so the idea is that you are either looping in or looping out, depending on the direction that you want. But yeah, there's a lot of details about like exactly how it's implemented. Like, and also there's different variations. So in loop in, we actually have like, or in loop out, we actually have the user generate the pre-image. In submarine swaps, like that I implemented before, the pre-image is generated by whoever created that invoice. So there's lots of different variations about how that actual workflow can be carried out. But basically, the idea is just the same as Lightning. You have HTLCs where it's economically incentivized to carry on this flow.
Sorry, just a basic question. So the on-chain outgoing transaction has to happen first and confirm for a few blocks before the HTLC off-chain can go out, right? That's the usual flow.
Well, it depends who's in control of the pre-image. But like we're setting up this theoretical HTLC, right? So before, like let's say I don't know the pre-image. So I'm the swap provider and I don't know the pre-image. So I get one HTLC locked to me that's of 1 and it's to a hash. I don't know the pre-image. I get another HTLC locked to me that's of 1. It's to the same pre-image, same hash. And then they tell me, hey, if you put these funds on chain to that same hash, that actually I'll reveal the pre-image to you. Plus, you'll take the difference. So then I send it on chain. And yes, you have to wait for confirmations at that point, because what if I double spent? So you wait for confirmations. Okay, that HTLC is locked, and now I reveal the pre-image. Now I sweep that chain funds, and I'm racing the timeout in that case, just like you can see here. But I sweep it into my own sole control using the pre-image, and now I know the pre-image because I saw you sweep it on the chain. So I take that pre-image and I use it to claim the incoming HTLCs off chain. I hope I'm cool for time. Yeah. Oh yeah, more questions.
About you said you were looking into two-party ECDSA.
Yes, we have a working version that will run on the chain.
Which variety of two-party ECDSA are you using?
I don't know. Connor has some code up there. We're not seriously pursuing it at the moment because it looks like Moosig is, full steam ahead. But potentially, it's nice because you have a greater anonymity set because everybody's using ECDSA, and also if the stars don't align for Moosig, we have another option. Okay, so privacy. So yeah, this is a complicated slide. So I talked about the AMP. So how AMP can get a huge multiplication. I talked about signature aggregation, how signature aggregation can get a huge optimization. And that's just for loop in. For loop out, the optimization is even better. If I want to do a loop out, so a loop out means that a lot of people want to move their funds within their channels. It's in their Lightning existing balances, and they want to move it out. They want to move it onto the chain. So currently, what I'm having to do to run this service is I have a bunch of UTXOs that I have to fan out, and then every time somebody wants to do one of these swaps, I have to select one of those UTXOs and then map it into the swap operation. And so there's a bunch of overhead to running the service, and it's also requiring these two fundamental chain transactions. Plus, there's change in every one of these operations. With Hyperloop loop out, instead I just select one massive UTXO. So I just have one super UTXO, and it's feeding into this multisig, this super multisig. And we still have the failure case. So if people stop cooperating, we still go back into the normal submarine swap HTLC case that goes on chain. But if they do cooperate, then I create a transaction that has all the outputs that everybody wants. So and AMP also works in this case. So I want to empty out 10 channels. So I can make 10 HTLCs going back to the swap provider, and then I can get reimbursed with one on-chain output. Okay, so let's look at how the Hyperloop chain transactions look. So this is kind of like the same. It looks a lot like the first chain transactions, but there's a super key difference. And I'm only talking about loop out in this case. So in loop out, we can have lots and lots of people participate in this loop out because we're aggregating all of these signatures. So we only have one signature, and we're also using the UTXO, like we're using a monster UTXO to feed into this swap operation. So we don't have like lots of different UTXOs going into this transaction because the swap provider is providing that UTXO. And the only additional cost for each additional individual who's operating within the swap is we need to have a value for them, and we need to have a script pub, so like their address. That's all that's needed for every single additional person. So before we saw that the chain vbytes was around 300 altogether, but now not only do we have a lower chain cost of around 200 for an individual swap, the more people that we add into the swap, we're adding 10 times less vbytes for every person who's participating, and potentially these people are also doing many, many channel swaps. So if you're doing 10 channel swaps, then each person is only 3 vbytes. So that's like a factor of 100 on top of chain efficiency that we can like wring out using all these fancy technologies. And like Taproot is a potential like improvement on like the worst case scenarios, but we don't even really need it. What we really need is signature aggregation and atomic multipath payments, and that delivers like a huge savings. That's it. Questions? Yeah.
Yeah, Submarine swaps for privacy, people are using, I mean, because you are able to break the on-chain
you break the.
transaction.
I don't know if it's like an advertised feature, but it definitely is a possibility that you can get some privacy wins, especially if we can move the HLCs to be out.
Yeah.
The only key is that we need to improve the way that we do privacy on the server side. So right now we have kind of like your IP address,
I
and
think you should use 2 different swap providers, one for getting and other for get out. But
yeah, I think that there could be big privacy benefits. Although there will be a cost, right? Every time you loop, there's a chain fee, so it will cost some money.
yeah, it's cool.